So this first question we have here says the cone has a height of 24 inches and a radius of 8 inches. Find the area of a cross section 6 inches from the vertex of the cone. So here's the vertex of the cone. It's the point at the bottom that's 6 inches away right there. Well, we know that these triangles are similar triangles because these angles, these are both right angles here, and these angles would be the same because these are parallel lines. So that's one piece of information that maybe you didn't know. So these are proportionate. So it says the cone has a height of 24 inches. So the entire height is 24 inches. So this is 24 right here. And we know that that's x, so or 8, so we're going to call this x right here. So we know 24 is to 8 as 6, which is the height of that portion, is to x.
Wait, how's it 24 again?
Because it said the height of the cone was 24 inches.
Oh, sorry, I didn't read that.
Okay, so now what we do is we cross multiply this. So this is 24x equals 8 times 6. Now notice I'm not actually multiplying the 8 and the 6 together. You'll see why in a second. So x equals, divide by 24. X equals 8 times 6 over 24. And I'm going to just cancel the 24 and the 8 because you know 24 is 8 times 3, right? So there's 3. And then I'm going to cancel the 3 and the 6 because 6 is 3 times 2. And so this just equals 2. So x equals 2. Now we needed to find that because they wanted the area of a cross section. So they wanted the area of this right here. I'll do it in yellow. They wanted the area of this right here. So I needed to find x because x is the radius, right? So x is the radius of that cross section, or so the area of a circle equals pi r squared, and r is 2, so it's just 4 pi. Okay. Questions about that? You guys good with that? All right, the next question, 58, says, find the area of a cross section 12 units from the center of a sphere with a radius of 13. So this sphere has radius 13. So that distance is 13. And they'd say that it's 12 units from the center. So this distance here is 12. Okay. Find the area of a cross section of 12 units from the center. Okay, so they want us to find this area, the area of this right here. That's what they want us to find. This is a radius. That's exactly right. Because that is a radius as well. There's your 13. Much better. So this we know now because this is the hypotenuse. 13 is the hypotenuse. That's why this distance is 5 right here. Because 5, 12, 13 is one of those special right triangles. 5 squared plus 12 squared equals 13 squared. 25 plus 144 equals 169. Got it? Does everybody understand that? Special right triangles. 3, 4, 5 is another one. And there's several other, I'm sorry, I'm calling them special right. No, those are Pythagorean triples. Pythagorean triples, those are all numbers that work together with the Pythagorean formula. Everybody get that? So 5, 12, 13 is one. It's just good to memorize that, like 3, 4, 5, or any multiples of those. Okay. All right. So since we found that, thank you, Sumeda. Was that you, Sumeda? Thank you for pointing that out.
Yeah.
Now we know that that orange or that yellow circle, the area of that yellow circle, again, it's just pi r squared, so it's just 25 pi. Very good. Yeah, I was making that problem harder than it actually was. And by the way, let that just be a lesson to you all. I've got my master's in mathematics. I teach this all the time, but sometimes you don't remember. Sometimes something doesn't come to you and it takes a little while for you to figure it out, and that's okay. And sometimes you go down and you follow one string of thought and you realize, nope, that was none of that I needed to do. Maybe I need to start over. Maybe I just need to take a new piece of paper out and try it from scratch again and start thinking of it from a different angle. No pun intended. All right. Next page, in the parallelogram ABCD, B is -4, 6, D is 4, 10. Find the coordinate where the diagonals will intersect. Find the coordinate where the diagonals will intersect. Okay. So you know it's a parallelogram. So I'm going to borrow this down here to do number 24. -4, 6 is -4, 1, 2, 3, 4, 5, 6, all the way up there. So there's -4, 6. And 4, 10, well, that's going to be way too high, but that's okay. 4, 6, 7, 8, 9, 10. So there's 4, 10 up there. And there's -4, 6 right there. It says that in the parallelogram that those are your B and D. So C, so this was your, let's see, this was B and this was D up here. So A and C are going to be somewhere here and here. It's a parallelogram. Find the coordinate where the diagonals will intersect. Well, the diagonals bisect each other, right? Diagonals of a parallelogram bisect each other. So basically all we have to do, another way to ask this question is find the midpoint. You guys understand that?
Yeah.
Just have to find the midpoint. So how do I find the midpoint of this? Well, the midpoint is going to be, I take the x's and add them together and divide by 2. So 4 plus -4 divided by 2, which is 0, and 10 plus 6 divided by 2, which is 8. So my coordinates are going to be 0, 8. Good. Questions about that, anybody? I will erase this now and do number 26. Given the rhombus RHOM with H here and there, what is the slope of RO? All right, so let's just draw it in here. 7, -3. 1, 2, 3, 4, 5, 6, 7. -3 is right here. There's your H. And 2, 5, 2, 1, 2, 3, 4, 5, 2, 5 is right there. That's your M. So RHOM. What is the slope of RO? Well, what do we know about rhombuses? What are some of the properties of rhombuses that we know? Anybody, can anyone think of a property of rhombus?
Diagonals are perpendicular.
The what? Say that again.
Their diagonals are perpendicular.
Good. So since the diagonals are perpendicular, since we know that, if we find the slope of this line, what can we do to find the slope of the other line? RO. We know it has to be what? It has to be the negative reciprocal.
Yeah.
Remember, negative reciprocals, reciprocal. So all I have to do is find the slope of that red line and then take the negative reciprocal of that. So let's do that. The slope of the red line, let me show you a little trick here. If you have them plotted on the point anyway, the slope is just going to be the rise over the run. So you can just see it right here. It's 5 plus 3, so it's 8, but it's going to be -8. So the slope of the red line is going to be -8 is the rise because it's going down, over the run is just this distance right here, which is 5, -8/5. You could also use that formula. y2 minus y1 over x2 minus x1. But that's when you have it plotted already, it's easier, in my opinion, to just kind of look at it on your graph, count from here to there, and count from here to there. That's the rise and the run. Got that? And so the slope of the RO is going to be the negative reciprocal, which is going to be 5 over 8. So there's your answer. Questions about that? All right. Number 21, how many diagonals does an 18-gon have? Well, if you know the formula,
We're told to skip.
for the diagonals, anybody know what the formula is?
We didn't learn this, so we were told to skip this question.
Oh,
Yeah, on the answer key it said that.
all right. Let's not even do it then. I don't want to confuse you. There's a formula for it, but it's all good. Number 35, find the area of the figure to the nearest 10th. Ooh, all right. Well, the area of this figure is going to be the area of this rectangle, right? And then it's going to be the area of this quarter circle. Do you follow? So the area of the rectangle is just going to be 6 by 3. So the area of that is 18. Got it, everybody? And the area of this right here is going to be 1/4 of the area of the circle. And that circle's area, that's radius is 3. So the circle's area is pi r squared, so it's 9 pi. So the area of that entire figure is going to be 18 plus 9/4 pi. Now they want it to the nearest 10th, so now you can plug this into your calculator. Very carefully plug it in, I'll leave that to you, and then round it to the nearest 10th, but don't round until the very end. Okay, and you then don't use 3.14 unless they tell you to. Next page. Stop me if you guys have questions, okay? This says, in circle P, find the length of AB given that the radius is 7 inches and that angle measure is APB equals 4 radians. Okay, so let's just draw a picture and see what they're talking about here. So here's my circle. We know the radius of the circle is 7 inches. And we know the length of let's see, they want to find the length of AB. So this is P here. Okay, so A is, let's see, 4 radians. So it's going to be something like this right here. So here, so what they mean is what's the length of AB? That's arc AB. And they're telling us that the angle measure right here is 4 radians. So this is 7 inches. This angle measurement here is 4 radians. Now let me just to clarify for you guys, because maybe you're having a hard time with the concept of a radian. A radian is an angle measure, kind of like a degree. So when you're measuring lengths, you can measure in inches, you can measure in centimeters, you can measure in meters, etc. When you're measuring angles, there's 2 ways to measure angles, either radians or degrees. And radians have to do with the radius of a given circle. So when I'm looking at when I'm looking at a full circle, this has 360 degrees from all the way around. It's 360 degrees all the way around, or it's 2 pi radians all the way around. So a radian is related to the radius. And let me explain it to you. If this is the radius of the circle, right? Well, what's 2 pi radians roughly? It's like 6.28 radians, right? Y'all follow me? So if this distance is one radius, then a radian would be if I wrapped that length, pretend like that's a shoestring. If I wrap this around here, there's 1. there's 2, there's 3, there's 4, there's 5, there's 6, and there's 0.28. That's what a radian, sorry, is. So this angle is 1 radius. Sorry, 1 radian. That angle is 1 radian. The angle measure where a radius is intercepted. Does that make sense? So this is 4 radians. I did this wrong then, sorry. 4 radians would be, here's 7, this is 7 inches right here. I'm sorry, 7. So if I went 7 inches around 4 times, that would be my my arc length. So here's my A and here's my B. That makes sense? So this distance right here, or this angle right here, is 4 radians. You could convert it to degrees if you want, but you don't need to. In fact, I didn't have to explain all of that to you to explain this problem. I just wanted to use that opportunity to explain radians because they confuse people often, but they're actually a very good way to measure a circle. And one of the reasons they're so good is because of this formula. The arc length is equal to r times theta if theta is in radians. So this is the arc length. So the arc length is equal to 7 times 4. That's all you have to do. So S equals the arc length of AB is simply equal to the radius, which is 7, times the radians, which is 4, which means the arc length is simply equal to 28 inches. And you can kind of see it based upon what I just told you. This is 1 radius, so that's like 7 inches. This is another radius, so that's 7 inches. This is another radius, so that's 7 inches. This is another radius, so that's 7 inches. So how many total inches around the circumference did I go? 28 inches around the circumference. That make sense? All right. Part B says, find the intercepted arc length if S equals 3 centimeters, denotes the length of the arc of a circle with radius 5 with the central angle theta. Find the angle. Find, okay, hold on. This is confusing. Find the intercepted arc length if S equals 3 centimeters, denotes the length of the arc of a circle with radius 5 centimeters. They're telling me to find 2 different things. First, they're telling me to find the intercepted arc length. Then they're telling me to find, oh yeah, they're just saying it in a run-on sentence. They're basically telling me to find theta. They just said it twice, once at the beginning, once at the end. So again, let's just use this formula. S equals R theta, and we're trying to find theta. Well, what's S? 3. What's the radius? 5. So what's theta? 3/5. So your answer is 3/5. Theta equals 3/5 of a radian. Now, if they asked you to find it in terms of degrees, then you would take the radians right there, because remember, this formula only works for radians, not degrees. Then you would take this answer and you would convert it to degrees by multiplying it by 180 degrees over pi radians, which is a conversion factor. Okay, but they didn't ask you to do that. Next question. You need to paint a child's toy that is made up of a cylinder and a hemisphere, as shown. The radius of the cylinder is 14 and its altitude is 30. Small paint can cover that much. What is the surface area of the child's toy? They want us to keep it in terms of pi. Well, the surface area, we look at our formulas. The surface area of a cylinder is equal to I'm looking at the sheet. Now it says right cylinder on your formula sheet for the final exam. It says right cylinder, and it's got you've got to be kind of smart about this, because remember what I'm going to need is the bottom. I'm going to need this bottom circle, and I'm going to need this lateral area right there, but I don't need that top circle, because that top circle, I'm not painting that top circle, I'm painting this dome here. I'll follow what I'm saying. So you kind of have to think through it, look at the formulas and be smart about it. So the surface area of that cylinder, not including that top part of it, is going to be the lateral area of the cylinder, which is the which is 2 pi r, because that's your circumference. So this is the circumference of that circle. It's 2 pi r times h, the height. But then I'm going to have to add just one of the area, one of the circles, the circle at the bottom. I'll color code this for you. So it's 2 pi r times pi r squared, but I only need one of them. That's the surface area of the cylinder. Now the surface area of the sphere, the surface area of the sphere, and it's really a hemisphere, so I'm going to write HS because it's half of the sphere. So if I look at the surface area of a sphere, it's 4 pi r squared. But then I'm going to take half of that because it's a hemisphere. So basically it's just 2 pi r squared. And now let's plug in everything that we need. So we know that the radius is 14. So it's 2 pi times 14 times the height. The height is 30, plus pi times the radius, which is 14 squared, plus, so that's the cylinder, right? Plus 2 pi 14 squared. Got it? And I will leave it up to you to simplify all that, to punch it into your calculator. They actually wanted you to keep it in terms of pi. You can see the answer on the answer key there. Now B says how many cans are needed to paint the surface if it requires 2 coats. Well, now what you would do is you would notice that the small paint can covers 200 or 2000 centimeters squared. So whatever this answer is right here, you would divide that answer by 200, or sorry, 2000. I'm sorry. No, you would divide 2000 by that answer, right? Because you've got 2000. No, I said it right the first time. Sorry, I'm thinking through it. If that answer was 1000, then you would need 2 paint cans, right? Oh, I'm sorry. It says you need 2 coats of it. So we're going to have to multiply the answer by 2. So whatever that answer is, because we're doing 2 coats, you're going to multiply that by 2. So let's say that that was 500. The answer was 500. Times 2 would be 1000. So 1000 divided by 2, you would only use half. You'd only use half of the can, and that would be, you wouldn't need any more cans. But if that answer was 7, let's see, if that answer was 1200, if your answer for part A was 1200, then 2 coats of that would be 2400. 2400 divided by 2000, you would need another can to coat it, because there'd be a remainder left over. So you would need another can. You would need another can. They're not asking you, they're not telling you that you can buy like part of a can. You basically have to buy enough to cover it twice, and you'll have some paint left over. Does that make sense, everybody? Yes, good.
So it's like 4.5 cans, but you can't have a half can, so it's like 5 cans.
Correct.
right?
Thank you. So what was the screen answer up here, guys?
It was 5.
I'm sorry, for part A, what was the total surface area?
1 second. 1,428 pi.
1,428?
Pi, yeah.
Oh, well, go ahead and multiply it by pi. Tell me what the number is.
It's like 8,248, something like that.
8,248?
Yeah, something like that.
We're gonna
It
need
should
more
give
than
you like,
Oh, wait, did you multiply that by 2?
yeah, it's multiplied by 2. You get like 4.5.
Oh, got it. Okay, so your number was like 8,428, like that.
Yeah, something like that. Yeah.
And when you divide it by 2, you're gonna realize that you'll actually need 5 cans, because 4 cans wouldn't be enough. 4 cans
Yeah.
only give you 8,000 square feet, so you need 5.
Yeah. Right. Okay. Yeah. I just wanted, and also for part A,
Say again?
can I have? Sorry.
Yeah, for part A, go ahead. Say your question again.
Yeah, so it's made up of a hemisphere, right? And hemisphere's surface area formula 3 pi r squared. So if you take out like the base, it would be 2 pi squared then?
No, the surface area of a sphere is 4 pi r squared, not 3. You're looking at the volume. I think maybe you're looking at the volume.
It says a cylinder and a hemisphere, right?
Yeah, it's a hemisphere, but a hemisphere would be half of a sphere. The surface area of a hemisphere is basically half of the surface area of a sphere. So it'd be
Okay,
2
yeah.
pi r squared.
Okay. Yeah.
Did that answer your question?
Yeah.
Okay. Next question says, find the length of one side of the regular polygon shown in simplified radical form. Okay. So we know it's a regular polygon, so we know that all of these angles are the same. And so we're basically trying to find this length right here. All right, so we do know we can find the angle. So what I'm going to do is I'm going to draw in. You can see that if I draw in all of these lines, they're not radiuses because it's not a circle, but you get the idea. If I draw in all those lines to the vertices from the center, there are 6 of those, which means this 360 degrees right here divided by 6, 360 divided by 6 is 60 degrees. So each of these is 60 degrees, which means this is half of that. So this is 30 degrees right here. This angle right here is 30 degrees. Let me zoom in on that. This was 12. This is 30 degrees. You follow how I came up with that? And since that's 30, this one down here has to be 60. Hey, this is a 30, 60, 90 triangle. And you remember the relationship in the 30, 60, 90 triangle? You guys remember the trick to get from the medium side to the small side, rather? Remember how to get from here to here? You would divide by square root of 3. Do y'all remember that? 30, 60, 90 triangles, how to go from the medium side to the small side?
Yeah.
There's other ways to do this, but that's the way that I think that's the way they would expect to do it. You could use trig to do this, but you guys don't know trig yet. So you can't use trig. When you get to that, there's a different way you could do it. But for this special right triangle 30, 60, 90, you know that whatever side this is right here, call this C, and we'll call this B, and we'll call this A. You know that A squared plus B squared equals C squared. But you also know, since this is a 60, you also know that since this is a 30, 60, 90 triangle, you know that C and B, C is twice of B. And because of that, you know the relationship between A and B as well, which is the square root of 3. I'm not going to go into the explanation for that, but just trust me. To go from this side to this side, you divide by square root of 3. Okay, so this is the medium side. This is the small side. This is the hypotenuse. To go from the medium side to the small side, you divide by square root of 3 if it's a 30, 60, 90 triangle. So this side B is equal to 12 divided by the square root of 3. And that's really what I needed, because they wanted me to know, they want to know the length of one side of the regular polygon. So the length of one of these sides is going to be basically double that. So this is just that little part right there. So that's 12 over the square root of 3. And so is this. So add them together, you get 24 over the square root of 3. Now they want us to show it in simplified radical form. This is not simplified because you can't divide by the square root of 3. So what I need to do is rationalize the denominator, multiply by the square root of 3 over the square root of 3. That will turn this into 3 rather. And so I've got 24 over the square root of 3. I'm sorry, 24 square roots of 3 divided by 3. And these cancel out into 8. So 8 root 3 is your answer. Questions about that? I know I did a lot of stuff on there. Lots of algebra, but that's correct. All right, so number 38, a regular hexagon is inscribed in a circle with a radius of 18. Find the area of the shaded region to the nearest 10th. Okay, so the area of the shaded region is, so I'm gonna have to take the area of the circle and subtract the area of the hexagon. So the area of the circle is pretty easy. It's just pi r squared. The area of the hexagon is the trickier part. So I'm going to do this in red. So how do I find the area of the hexagon? Well, I know this is 18 right here. And I know since it's a hexagon, just like I showed you up here in number 37, I know that this is a 60-degree angle, right? So there's this, the area of a regular polygon. You guys remember that? I'm looking at the formula sheet, making sure it's on here. The area of a regular polygon is equal to 1/2 apothem times the perimeter. You guys understand that? And this is your apothem right here. That yellow line is your apothem. Hey, guess what? We just talked about how to find that. Remember, that's a 30, 60, 90 triangle. So this is going to be half. This distance here is going to be half of 18. So that's 9. And instead of dividing by the square root of 3, if I'm going from the smaller side to the medium length side, I multiply by the square root of 3. So this is 9 square roots of 3. So the apothem is 9 square root of 3. And the perimeter, well, that's just 18 times 6, because there's 6 of those. So 18 times 6. Let's be smart. Let's just take the half and divide out one of these things. Why not divide out the 18, make it 9 instead? 9 times 6 is 54, times 9, whatever that is. So this, let's see, it says nearest 10th, but don't round until the very end. So here's my answer. It's going to be, I'm punching it in my calculator just so I make sure I'm doing it right. It's going to be 9 times 6 times 9. So that's 486 square roots of 3. So now I'm going to punch that into my calculator. Actually, no, I'm not going to do that. I'm going to let you guys do that. So this is your, this basically is your answer, but you have to punch it into your calculator now that it wants you to round it to the nearest 10th. So literally punch that in directly in your calculator. There it is. Got it. Okay, geometric Giovanni is a whopping 7 feet tall. He's waiting for his friend 13 feet away from the movie theater. As he gazes up to the top of the movie theater, he notices that he's looking up at a 43-degree angle. It's pretty impressive that he knows that. So here's the movie theater. And he is waiting for his friends 13 feet away. So 13 feet is right here. He's 7 feet tall, so he's right here. And he is looking up. He notices he's looking up at a 43-degree angle. So that's off of here. This angle is 43 degrees. Everybody got it? How tall is the movie theater? So they want to know this distance right here. Got it? So how do I find X? That's a good question.
For this question, I used trigonometry and then I added 7.
Yeah, I did the same thing.
Yeah, we've learned trigonometry before, so.
You have learned trigonometry?
Yeah,
Yeah.
with
I'm
basic
trying to
science.
figure out a way to do this problem without trigonometry, because when you know trig, you kind of want to use it. But we haven't technically learned that in this class, correct?
We've had a
Yeah,
couple
we have.
lessons on that.
Oh, you did? Oh,
Yeah.
okay. Okay. For some reason, I thought that we hadn't learned the trig that's necessary to do this problem.
Yeah, we did.
Yeah, so this is 13 right here. And you know, this part is 7 right here. And this is going to be x minus 7 up here if we're calling this whole thing x over here. So if we call this entire distance is what they're asking us for, that's x. This part, this portion up here would be x minus 7. And so you can use, this is the opposite, and this is the adjacent. So the tangent of 43 equals the opposite. We'll call it A for now. It's the opposite over the adjacent, whoops, over 13. So A equals 13 tangent 43. So punch that into your calculator, 13 tan 43. Oh, there's my calculator. I was clicking on the wrong calculator. I knew that I had one that was like this. 13 tan 43 equals 12.12. What do they tell us to round it to? 10th, 12.1. So this is 12.1 right here. So add 7 to that, and that gives you the total height of that movie theater. So
Yeah, even I did that, but I wasn't sure if you should add 7 or not. I just wanted to make sure I did it the right way.
Yeah, then you add 7. So A is 12.1. So add 7. It's 12.1 plus 7. So it's 19.1.
Yeah, I just wanted to make sure I did it right.
Yep. Is that what the answer key says?
Yes.
Yep. That's it.